Okay, everybody, I'm going to show you how you could use Logger Pro to do a video analysis. Logger Pro is a little bit easier to use than Tracker, and we have a school license for Logger Pro, so you can install this program on your PC at home if you'd like to do that. So I've already installed the program and started it, and I am going to now open up a video. So what I'm going to show you would work for any video. I'm going to load a video that gets installed with the program, but it'll work with other videos as well. So let's see here. I'm going to open up this video here. So here's the video. It's a basketball player. Oops, let's see here. Take it to the beginning. So there's a slider for the timeline and you can just press play. So it's someone shooting a basketball. So I'm just going to back it up to the part where I start to care about it, which is just after he lets go. So probably something like that. And we have to click on this button here to open up the tracking software. So first of all, we have to do is set a scale. When we're analyzing a video, the computer, it doesn't know if it's looking at a person or an ant. It has no idea of scale. So we have to tell it the scale. And I happen to know that in this video, that the distance from here to here is 2 meters because I read that about the video. So I click on this set scale ruler and I go from there, click and drag to there, and I'm going to tell the software that it's 2 meters. The other thing we have to do is set an origin. So just you can put it anywhere. I know usually we like to work with numbers that are positive, and since the ball can move up and over from this direction, I'm going to start with my origin down here. Therefore, I know all my values will be positive. So that's it for the setup. Now we want to track the position. So I press, and we're just tracking one single object, which makes it a bit easier. So I'm going to click on this at a point, and I'm just going to track the center of the basketball. So I'll click there, it moves a little bit. So every time I click, it just moves forward one frame. So I have to do this several times. The one nice thing about the other software, the tracker software, is once you find an object, it can try to track it automatically, so you don't have to go through this. But it's kind of tricky, and you just have to do this once, and it's all good. So I'll just keep clicking these things. And once the object's tracked, I can show you how the analysis works. It's very similar. Actually, the analysis is the same as the Vernier graphical analysis software that you've used in class before. So that's good enough, I think. I'll do one more. Okay, so that's the video tracked. And here's the data. Well, there's the graph of the data. Here's the actual data. So it already knows that the X is the horizontal, or it actually set it up. So the X is the red, it's horizontal data. And the Y is the vertical data. And it already automatically calculated some X and Y information. So if I wanted to find out, this looks like it's a linear line. So that's the horizontal position time data. So if I select that data and I go up to here and I go linear fit, because I'm pretty sure that's a straight line. It's going to ask me, because I can select either the blue or the red. I want the X. So there you go. There's the equation of that line. It tells me the slope is 3.06 meters per second. Therefore, I have every reason to believe that the horizontal velocity of that basketball was 3.06 meters per second. So that's that. I'm going to get rid of that. There's a little X I can click on to get rid of it. I am interested in analyzing the vertical. And to do that, maybe I don't want to look at the parabola. Maybe I want to look at the Y velocity. So I can click on this and choose Y velocity. So there's the Y velocity. It looks like a straight line too. Maybe not right at the beginning, but certainly from here down. So I'm going to do a linear fit. And when I do that, I would expect that slope to be close to negative 9.8. If it isn't, then something's wrong. Either it's a fake video or maybe the scale I set up is incorrect. So let's check out and see what happens when I do a linear fit. And I will look at that. Negative 9.76. That's really close to negative 9.8. So that tells me that this is probably a good analysis, and not only is this vertical motion graphed correctly, but I have a lot of confidence now that that horizontal motion was graphed correctly as well. So these are the kind of tools you could use for your, if you want to use this for your video analysis for the project. Another thing, just an extra thing that some people might find kind of interesting. I'm going to go back just the Y data, the parabola. And let me see if I can type this somehow. I'm going to go file new. We know that vertical displacement could be something like Y equals V naught T plus 1/2 A T squared. In other words, when we have a parabola of a projectile, when we graph, where are we going here? When we graph Y versus T, if we get a parabola, if we can find a curve fit for that parabola, we know that the coefficient in front of the T squared is equal to 1/2 A. So that's what I'm going to look at right now. So I'm going to do a curve fit for this. Maybe I won't take the first point. I'm going to do curve fit, and it's not linear, so I'm going to do a different one, curve fit. And I can try a quadratic, a cubic, a quartic, whatever. I can try any kind of power. I'm pretty sure this is a quadratic, so that's why I've selected a quadratic. And there's a button here that says try fit, and I think it's just going to give me a preview of it. And it looks like that's a pretty good fit. And the correlation is 0.999904. If this was 1.0, it would be a perfect fit. So this is really close to a perfect fit. So I'm pretty confident that this is a quadratic. So I'm going to go OK. And here we could see it's fit a curve that's Y equals AT squared plus BT plus C. So A is the coefficient in front of T squared. And A is equal to negative 4.908. Totally makes sense because that's what we'd anticipate, because we know that the coefficient in front of T squared, is A, and A is equal to 1/2 acceleration. That's from this guy right here. So in my graph, A was negative 4.908. Therefore, acceleration is just twice that. So 9.81. Actually, just 9.8. So that's really good data as well. So that's not part of the project, but that's just for people that are moving forward in physics. We can start to analyze parabolas by themselves to get acceleration data from position time graphs. Anyways, there you go. That's how you use Logger Pro for tracking videos.